All right, so the next thing you're going to be looking at in section 4.1 is constructing and working with what's called a discrete probability distribution. So notice here, for right now, we are only going to be looking at discrete random variables. We'll talk about continuous distributions in the next chapter. But what that means is for all of these in 4.1 and 4.2, we're going to be looking at situations where we're interested in counting something. So for example, I went ahead and pulled an example of a distribution for you here, where notice the x, the random variable in this distribution, is counting the number of days of rain over a 3-day period. So that means this is a discrete random variable. Now, what a distribution does is it essentially summarizes the entire experiment. So what it's going to do is it's going to list all possible values for the random variable x. That's why this only works for discrete, because remember, with a continuous random variable, you have an infinite number of possibilities and you cannot create a list. So what it's going to do is it's going to list all possible values of the random variable in this first column here. And then along with each one of those possible values of x, possible outcomes, it's going to give the corresponding probability, denoted P of x, in the other column. So notice how I would read this. From the distribution, I can determine that the probability that there will be no rain, 0 days of rain across this 3-day period, is 0.216, about a 21.6% chance. The probability that there'll be 1 day of rain is 0.432, and so on. Now notice when I'm looking at a discrete distribution, I can also combine values together if I want to, but I want to stress to you that when you do that in a discrete distribution, you're going to be adding probabilities, not multiplying. And I know we've gotten very used to multiplying everything. So to give you an idea of what I mean here, let's say that I asked you to find the probability that there will be rain on at least 1 day. All right, what you would need to do in this case is think about what that at least one means and ensure that you're looking at the proper values that go along with it. So at least one is another way of stating one or more. All right, at least one means we have 1 day of rain, or 2 days of rain, or 3 days of rain. All right, that's what it means to be at least one. It's 1 or 2 or 3. So I want you to notice here these events, because they're joined by or, it's not sequential, it's not an and like what we saw in chapter 3. That is why we're going to add probabilities instead of multiplying them together. All right, multiplying is for and, for sequential. Adding is for or, events joined by or. So what I could do in this case is just reference my distribution, right? The probability that I'll have 1 day of rain is 0.432. The probability that I'll have 2 days of rain is 0.288. And the probability that I'll have 3 days of rain is 0.064. So to look at these in terms of at least one, I'm going to add them together. And that's going to tell me the probability that I'll have rain on at least 1 day is 0.784, or about a 78% chance. So that's the first thing you want to be able to do here is just read a distribution correctly. It's giving you probability. It's giving you all the information for that experiment. And so you just want to be able to pull the information that you need to answer a particular question about probability. Now, something else that you want to keep in mind, every discrete distribution must satisfy 2 properties. So sometimes you'll be asked to verify if something is a discrete distribution, and what that means is to ensure that it meets these 2 properties. First one's pretty quick to check. It just says all P of x, all probabilities are between 0 and 1. So I can just scan through here and I can see, yes, everything is between 0 and 1, so I'm good there. The second one here says if you take the sum of your probabilities, it should sum to 1. And this is relating much back to relative frequencies, right? We kind of already know that probabilities are relative frequencies, and we know that relative frequencies should sum to 1. So this is along that same thing. So to verify that, I would just add these values together. And if I do that, I am going to see they sum to 1. And so I have verified that this is indeed a discrete distribution. If either one of those did not happen, if either one of those properties was not met, then I would have to stop and say this is not a discrete distribution. All right, so you're going to be looking at reading a discrete distribution. You're going to be looking at verifying, checking the properties, and you're going to be looking at calculating descriptive values such as mean, variance, and standard deviation. All right, so we're going to look at our formulas here, but let's go ahead and do this with our distribution so we can put some numbers in there. When I'm asked for the mean, the formula here for calculating the mean of this distribution, notice it's denoted mu. These are always population parameters when we're dealing with a distribution. And my formula says take the sum of x times P of x. All right, so an easy thing to do here would just be to create a third column. Look at that information for each one. So if I multiply 0 times 0.216, of course that's 0. 1 times 0.432 is going to stay 0.432. 0.288 times 2 is 0.576. And 0.064 times 3 is 0.192. And so if I add those values together, that's going to give me a mean here. Now this is a mean value of x, so a mean of 1.2 days of rain. This is commonly referred to as an expected value. All right, so we're saying we would expect a little more than 1 day of rain over this 3-day period based on the discrete distribution that we have. All right, so that one pretty straightforward, not too bad to calculate. The next one that we're going to look for is our variance. And this one, just like it was back in chapter 2, can be a little time consuming if we're using the formula. So I'm just going to kind of give you an idea of what that would look like. My formula says take the sum of the deviation squared multiplied by probability. All right, so if I were going to do this by hand using my formula, then I would come up here and I would create, much like I did in chapter 2, I would create a new column where I subtract the mean, a column where I square, whoops, and then a column where I take that square, and fit it in here, and multiply by the probability. All right, so again, just to show you what this would look like for the first row here, x minus mu, all right, that means I need to take x, which is 0, subtract the mean, which is 1.2. All right, in my second row, x is 1, subtract the mean at 1.2. All right, now, in the next column, I'm going to square that information. So, for example, 0 minus 1.2 is negative 1.2. Squared is 1.44. And then in my last column here, I would take that square and multiply by the probability, which was 0.216. So I would fill in all these columns for my discrete distribution, and then to get my variance, I would simply take this last column and calculate the sum. Now, I'm not walking through all of this by hand because I'm not going to ask you guys to do all of this by hand, but I wanted to show you a little bit of it because if you click on the help tools for variance or standard deviation, this is what it's going to show you. It's going to show you walking through and using the formula, and you can absolutely do that. But because we did that in chapter 2, I'm not going to require you to do it by hand again here in chapter 3. So let me show you what this would look like if I wanted to use StatCrunch. So the first thing to note here is that I've just entered my distribution, right? X in variable 1, P of X in variable 2. Now, the main thing here to use StatCrunch, we're going to do this kind of like we did a weighted mean, is that the weights, if you will, have to be whole numbers. And right now the weights, the probabilities are not whole numbers. So the easiest thing to do, since these are the 3 decimal places, is just to multiply each one times 1,000. And it's okay to do this as long as you do the same thing to every single one. So I'm going to multiply each one, by 1,000. And then what I've done here is I have converted my probabilities to whole numbers, but I haven't changed anything because I did the exact same thing to each one. So if you multiply one of them by 1,000, you got to multiply all of them by 1,000. All right, and then what I'm going to do, like I said, much like what we did for the weighted mean, I'm going to go to Stat. Going to go to my summary stats because that's where I find values like mean and variance and standard deviation. But remember, the weighted values were done with the grouped or the binned data. So I'm going to come down here to this bottom one. I'm going to select variable 1, right? Those are my X values. But I'm not going to select variable 2. Notice how this says counts. That'll remind you it needs whole numbers. So right there, I'm going to use where I did the conversion to whole number values. All right, and then remember down here, you can pick and choose what you want, or you can let it give you a full rundown. I'm going to go ahead and pick what I want here. Notice I'm picking the unadjusted variance and standard deviation because I told you these are parameters when we're dealing with a distribution. And then I've also got my mean selected as well. All right, so variable 1, variable 3, the whole numbers, I've selected what I want. When I hit compute, right, notice there's my mean. I can check that. We just calculated that with the formula and got 1.2. But I can also state my variance if I had walked through that entire formula at 0.72. And then we already know to get standard deviation, we just take the square root of the variance, and that same thing holds true here. So I could take the square root of 0.72. That would give me a standard deviation, if I round this to 1 decimal place, of approximately 0.8. And remember, this is getting back to original units. So we're talking about 0.8 days of rain. That's the approximate amount of variation we would expect, right? So almost 1 day of rain variation around that mean of 1.2. And notice that information was given here. Oops. If I need to show up here. That information was also given here when I ran. So let me pull that up one more time. Summary stats, grouped data, variable 1, variable 3, I want my mean and then my unadjusted variance and standard deviation. And notice not only did it give me the variance at 0.72, but it also gave me the standard deviation rounded at 0.8. All right, so again, I want you to understand what the formula looks like and how you could, and if you finished out the table up there and added up that last column, you can check this. You'll get a variance of 0.72. But I also want you to practice using StatCrunch, converting to whole number weights, because again, I'm not going to require you to do this by hand here since we did this all by hand in Chapter 2.